Aloha. My name is James. I work at Zendesk. I am a senior user happiness engineer. You can find me on Twitter at James A. Rosen. You can find me on GitHub at James A. Rosen. You can find me pretty much everywhere at James A. Rosen. The A is important because James Rosen is a Fox News contributor and I am not. I'm here to talk to you about Carson. You can find these slides on GitHub, as well as most of the content written out for review later. An introduction. About 5 years ago, Zendesk was born as a Rails 1.2 application. It was a pretty standard application. Over the years, we've upgraded it many times, sometimes slightly less successfully than others. Over the years, we've also added a lot of non-Rails services. We started out with Sphinx for search. We changed that out to Solar after a while. We added eJabberD for chat. We switched that out to Node. We added Rescue for background jobs. And over the years, the code base has grown a lot. The red line is test, the blue line is code. So you can see that our engineers are pretty good about keeping our test coverage up. So that's very good. But over time, when you have a single app like this grow, your developer happiness starts high and shrinks. And the primary reason for this developer, I guess there are two primary reasons for this developer unhappiness: test time and interdependencies, or dependency management. So the first thing we took a stab at was the test time. And Corey Haynes had a great talk about a year and a half ago at GoGeRuko, where he talked about a fast test suite. And he showed us the holy grail of fast testing. He ran his whole Rails app test suite in 0.3 seconds or something. It was great. Everybody was wowed. What it turns out he did was he just extracted all of his code from its dependencies on slow things like the database, like Rails. And so then he could run his tests as very pure isolated Ruby. This is a change to your tests, but it's also a change to your code. So it does make you write better code over time. If you use a fast test-driven method, you will come away with very nicely interconnected blocks of code that are easy to test, and thus they are nice to have clients of. We started out with this for a little while. It went well, but it wasn't enough. We had many, many lines of code, and we couldn't get all of our test suites over to fast tests, and we were still running at an hour for a test suite and just a minute or two to run a single test just to boot up the Rails process. So we were still pretty far down on that developer happiness trough. We learned the hard way Conway's rule. Organizations that design systems are constrained to produce designs that are copies of the communication structures of these organizations. So what we found out was if we wanted to have fast tests and we wanted to have individual components, we had to have teams that looked like that. If you want to break up your Rails app, break up your team. Our first such project was called CMonster, the CMS. CMonster was a very classic Rails 2 engine. HTML pages, no real API activity, very little JavaScript, not much in the way of assets or custom styling. We just bootstrapped upon our existing infrastructure, our admin interface and similar. So we wrote this as a Rails 2 engine. The team was pretty separate. It went very well. It's still running in production today. What we did learn from this, though, was that Rails 2 is not very good at asset control for engines. This is fixed in Rails 3. The asset pipeline is really nice. It handles engines well. So if you drop in style sheets, JavaScript, images, they just show up in your Rails app, and you can reference them directly. In a Rails 2, you have to run a rake task to copy them in, and it's kind of a nightmare to manage. So when we got to our next project, the Zendesk App Market, we decided that it was time to get up to Rails 3. It was a very JavaScript-heavy app. It's basically an API plus JavaScript clients. There's almost no HTML pages to render, so although it's a good fit for Rails, it's a good fit for sort of the API version of Rails. So Rails 2 wasn't going to be good, we go for Rails 3. So we build out a proof of concept of Zendesk apps. And after I do that, I go to Zaphod, our head of operations. Not his real name, but it would be cool if it were. And I say, hey, Zaphod, we've got this nifty new Rails 3 app we're ready to launch. How can we get it running in production? What can I do to help you guys get it running? And Zaphod looked at me like I had exactly the wrong number of heads. We're not ready to provision, monitor, and deploy an entire new Rails 3 stack. We're very comfortable with our Rails 2 stack, and that's it. So here is where I may have misjudged Zaphod's stress level. And I said, but Zaphod, Rails 3 is the way of the future. Multiple apps is the way of the future. Service-oriented architects, single responsibility principle. Everything's going to be great if we have 1,000 Rails apps running in production. He was not happy. So meetings were held, and coffee was drunk, and Carson was born. Carson is our compromise. Takeaway here is communicate and love your ops team. What is Carson? I'll leave you with a quote. Carson is baby steps into SOA. I managed to negotiate with the infrastructure team that we could have a Rails 2 app and a Rails 3 app, but we wouldn't go any further than that. We wouldn't have hundreds or even dozens of Rails apps, just 2, and we could work from there. I was happy with this. So Carson is a Rails 3 app that isn't an app. All it has is configuration, a gem file, and some integration tests. If you want to build a vertical feature, a new feature in Zendesk, you build a Carson engine. So the provisioning team builds a provisioning engine, the email management team builds an email management engine. So if you have a vertical feature, you build an engine. If you have some sort of cross-cutting concern, logging or database internationalization, all that sort of stuff, those are classical gems. And then the only code that goes in Carson is initializers, things to sort of set up the environment. So did this work? From one respect, yes. We have small test suites across multiple projects. They run very fast. People are pretty happy with those. One extra nice thing is that each project only gets the CI build failure notifications for that project, so you don't end up with a lot of noise across teams. That's nice. But we're not really running our tests in the real environment. We're running them in a very fake, isolated environment. And so you need some integration tests. And this has been borne out by engines stepping on one another's toes, and I'll cover some how to avoid that later. But a few integration tests go a long way. The next benefit is semantic versioning. You have decoupled deploy schedules. So I don't know if you've been in this scenario. You develop a feature, you merge it into master, you're all excited for it to go out next Thursday with the next release, and somebody else merges, but there's a bug. QA holds up the deploy because somebody else's code. Now your code can't go out because there's a conflict on somebody else's. Carson is nice because these engines are built as separate gems that are semantically versioned. So you merge your stuff into master, you bump the version, you then redeploy Carson with your updated version, but you can deploy at will because everybody else's gems are locked to their current versions. It's a really nice way to avoid coupling these deploy schedules. Everybody can work on their own time. If you want patch updates and you obey semantic versioning, then it's as easily as bundle update my engine. If you use the tilde operator, then you'll just get patch updates to that engine, and those can go out pretty much at will because they intentionally don't have any functionality change. It's a little painful to do this without an internal gem server. So if you're going to try these baby steps, get an internal gem server running. If you're without an internal gem server, you're constantly doing these .get to a Git URL or a Git hash in your gem file, and you just have to be bumping those all the time. You'll end up spending an hour a day on just a gem file. The holy grail is to get here, where our continuous integration server can basically run all of the patch updates and redeploy every 15 minutes. So every engine, if it has patch deploys, they go out. And then if you want functionality deploys, big version bumps, you do those manually. Dependency management is fun. This talk was almost titled Carson because dependency management is fun. You do find that when you're working on isolated teams that need to coordinate, especially when they need to coordinate within a single runtime, you do have more meetings around dependencies. In a classic version, though, you should have been having the same meetings, you just probably weren't. You would go into your gem file and update the gem, and then you would hope that nothing breaks. Maybe you would run the tests, and that would give you some indication that nothing is breaking, but that would be about it. Here, the advantage is that the gem specs tell you who is relying on what versions, and a little bit about why, although still pretty limited information. So it is pretty hard to break other people's code by just updating a dependency. If we update JSON, the provisioning team can't work with the new version of JSON, it won't bundle and we won't be able to deploy. It does mean more meetings. And again, without an internal gem server, you end up with sort of more maintenance around your gem file and your gem spec. So stand up an internal gem server. Another benefit is deployment. So here, you were very possibly deploying a classic big ball of mud Rails app with Capistrano. You get the same thing here. And whenever a new project joins or starts up, they get free deployment. They don't have to build their own deployment mechanisms. They just jump on top of Carson, stick something in the gem file, and they get deployed just like everybody else. So that's a nice advantage over a real true SOA. And you can add as many features as you can fit in that runtime. It does mean you can't scale them independently. So if you have one service that receives 100 requests a day and one service that receives 1,000,000 requests a day, they're running in the same VM, and you just have to scale for the largest load. One downside is that you're going to have one single central database. You have a single app server, so it really can't communicate to multiple databases. There are some Rails active record add-ons that will communicate to multiple databases. It's tricky. Really here, this is a downside against real SOA, although it's no worse than what you're doing if you're going in this direction. Thunderbolt Labs has a great essay about why single central databases are bad. It mostly revolves around the idea of who is in charge of the schema. If multiple services need to interact with the same tables or the same data, there's really no way to know who is updating them at what time. So on to some patterns and some anti-patterns if you're going to work with this stuff. First is namespacing. Each engine gets a name, provisioning, for example. It gets a database table prefix, and a Ruby prefix, a database table prefix, internationalization keys. It has a set of routes for HTML pages, a set of routes for assets, and a set of routes for API endpoints. And all this makes it easy to know who owns what piece of functionality. Anti-pattern, unexpected global state. So we got bitten by this pretty early on. There's a lot of global state in a Rails app, even before you introduce any. So it's very easy to introduce global state. Ruby classes are global. Any class methods are global. But before you get to your code, there's Rails. And you've got i18n locale, the backend, the translation data, the database schema, the rack middleware, the MIME type mappings. The list goes on. It's very easy to run across global state in a Rails app. Here's an example from our code base. So the provisioning engine had an initializer that would set up a new internationalization backend for itself. And it just added its own translation YAML files to the set. But that meant that the next time we deployed, the Zendesk apps engine didn't have any translations because this was clobbering ours. So the way to solve this is agree on a convention and then encode that convention as a gem. Don't just agree on it. Somebody's going to forget to do it. So actually write code that expresses what you are agreeing on, and then each engine that cares about that convention includes that. And so when you want to change the convention, then you have to update all of the gems. So here, the convention was something. The convention we agreed upon was that each engine could register its own things, but it couldn't overwrite the global. It could only ask to be added to the list. And we've encoded that as a Zendesk i18n gem, and each engine just initializes itself, its own internationalization. And whatever we've written inside that gem handles how to arbitrate among gems. So beware of global state. As a bonus takeaway, encode your conventions as gems. A pattern, active support notifications. If you're working in Rails 3, this is a great framework. I hope everybody's using it. You can get great cross-domain notifications, not cross-HTTP domain, but cross your own modeling domain communication by using these notifications. So every time an account is updated, we announce that the account has been updated and anyone who cares can listen. Caching, but also all sorts of other things that care about accounts. So users for all of those accounts may get notices. Even better than this, though, is if you use very domain-specific events. So instead of just announcing that the account was changed, announce that the SSL certificate was updated. That way the people who care about SSL certificates don't have to parse into the object that's sent with the notification message and find out, and the people who don't care about SSL certificate changes don't have to receive and then throw away a message. If there is one big takeaway from this, it is this anti-pattern, shared mutable objects. For those who were in the evented talk earlier, and those who watched the keynote about parallelization, P312N, you know that shared mutable objects are a great way to commit a denial of service attack against your fellow programmers. It's really easy to step on each other's toes. Avoid it. So about a year ago, Reg Braithwaite wrote a great article called Williams, Master of the Come From, where he described a former coworker who had a particularly ingenious form of dependency injection and decoupling. This was Williams. Williams is a classic Rails app approach when you have a person that has many comments and a comment belongs to a person. Each model knows about its own relationship to the other. In a Williams Rails app, though, he would analyze what parts of the app depended on others. So the person system can exist alone, but the commenting system can't exist without the person system. So he would write this as this. In the person module, it would just know about people. And in the commenting module, it would know about both. At first glance, this seems like a really good fit for a Carson engine. The engine that knows about people, and the engine that knows about people and commenting. Turns out that this is actually a really bad idea. Again, it's an easy way to commit a denial of service attack against your fellow programmers. If in the commenting module you monkey patch in a validation that isn't actually needed for other engines, then you can prevent people from signing up to your site. That's a pretty obvious one. It's probably one that most people in this room wouldn't commit. But a slightly more nefarious one is just a before save callback that could possibly fail using some third-party service or some other service of your own, like an email notification service. So if you had an email, if you had a email communication engine, you might try to monkey patch this into person and then blow up your signups when your email server goes down. So the rule is, if it's not your data and it's not your code, you don't get to change it. So one solution we've come up with is copies of model classes. They're backed by the same database table, but it's not your code and it's not your data, so you're not allowed to change it. So in the commenting engine, you would have a version of people called authors. It uses the same database table, but it's read-only. You can't write back to another person's table. And that way you can read in their data, you can build your own relationships with those objects, and you're not monkey patching somebody else's code, and you're not writing to their data. This works pretty well. It's a very good start. Let's look at the dependencies. So we're dependent on the fact that we're running against the same database. As long as we're inside this Carson container, that's fine. We're depending on the fact that there's a people table, and that has a primary key column called ID. And those are all pretty stable dependencies, so I'm all right with those. If you start to get more dependencies, like you want more of the columns from the people table, you're doing more than just having something onto which to hook a relationship, a belongs to relationship, then you start to get more unstable because the people engine could change its database schemas since it owns those tables at any time, and you have no idea what's going to happen. If you start loading in people and their roles and their permission sets and their permissions, I would avoid, this kind of a structure for that. Basically what it comes down to is you have an engine depending on another engine, rather than an engine depending on a cross-cutting concern. So slightly better, we can have the people engine declare a public API that all the other engines can use. They declare a public method called lookup, and it returns to you something that quacks like a person. Maybe it is a person that's been modified. Here, that's what we're doing. We're just returning an instance of person, and we're marking it as read-only. But this API could be changed internally to make it more protected or add features or anything, as long as we obey the contract of lookup. This is pretty good. This is, I would say this is a step better than sharing the database tables. Again, we're depending on the fact that the engines are in the same container, because to make that Ruby call, you've got to make it inside the VM. You're depending on the people person class, and that it has a method called lookup that takes an ID. And those are all, again, pretty stable. So I'm fine with those. Again, though, we have this sort of engine depending on engine. It's calling directly into another engine instead of using a service layer. The other problem is that Ruby doesn't have package privacy, and this is the one point where I'm going to say, I wish I were writing Java. I'm never going to say that again. You could, in the commenting engine, say people, person, all. Nothing prevents you from doing that other than convention, and this is what we want to avoid, getting an actual writable version of somebody else's object. The best thing is something I learned from, I think some of the Square engineers were talking about this a little while ago. Before they write a service, they write the client to the service. So the very first thing they do when they're standing up a new feature is they write the API client. Maybe it's in Ruby, maybe it's Bash, maybe it's just HTTP, JavaScript, and a web page. Whatever it is, it defines what the service is going to be. So when the people team is building their service, the first thing they do is they build a service layer for that all of the other gems can consume. And this thing defines the person lookup method. The nice thing is that this lets you change the underlying implementation. Here we've changed it from an in-memory lookup to one that's an external service call over JSON. This means that if we decide we want to go from Carson to a real service-oriented architecture, we can just extract the people service into its own runtime, and as long as it has declared the client properly, nobody else has to change any code. So each feature builds a consumer gem, and there are no engine-to-engine dependencies. It's very good. You also get semantic versioning. So if the people engine decides it wants to change its API, it changes the client along with it, and all of the gems have to update if there are API changes, public API changes. So only modify your own code or data. Chapter 5, the future, which I'm going to lie about. Carson is no worse than a big ball of mud. It's worse in some ways. And why would you do it? You would do it because it's a stepping stone to SOA. And is it a stepping stone? Sort of. Carson is a good way to think about how to start decoupling your application. So if you have a big ball of mud right now, I would say think about these slides, think about doing it. I'm not necessarily recommending that everybody rush out and build this architecture. It has a number of drawbacks, particularly around dependency management, coordination. But these are things that you're going to have trouble with either in a Carson-like environment or a real SOA environment. So I think it starts to raise the right questions as you're getting away from big ball of mud. It is easier for a team to move to this than it is to start extracting full services. The one caveat is that it's maybe easy to get stuck in this, and if this is going to hold you back from real SOA, I would avoid that. But if it's going to help you get there, I would use it. This is a stepping stone. I hope we don't end up staying here for, years. Months is fine. I'm happy with that. It's gotten us some good gains in terms of developer speed, in terms of deployability. I think there are a lot of good things here in the short term. I work for Zendesk. We are hiring. And I've got a whole bunch of extra reading if you're interested. All sorts of great stuff. And I would like to open it up for questions. How do we handle database migrations? So in Rails 3, this is really nice. Each engine can can write its own migrations. And then in Carson, or the Rails container, you do rake your engine name, install migrations, and it will copy those migrations over into the host application, which then runs them. We internally at Zendesk have a little problem with this in that we have the Rails 2 application and the Rails 3 application, so it's hard to know who is in charge of the migrations. We've just settled that those all go into the Rails 2. But if you have a single big ball of mud that's already on Rails 3, this is really easy. This is a no-brainer for a Rails 3 app. For Rails 2, you have to copy in those migrations manually. I believe someone has written a gem that will do that for you, just sort of backported the functionality from Rails 3, but I would have to find it. If you're interested, let me know. So the question is, how do you decide which pieces to break off first? Where do you go for services? So I think, for me, the best answer is let your tests guide you. Find out what's very hard to test and try to write tests for it. And as you try to write tests for it, it will tell you what a real client would like out of that service. So a test is just any other client. And anything that has a good API for tests has a good API for other clients, by and large. Look for things that can be offloaded or delayed. So if you were in Zach Holman's talk earlier, he talked about how at GitHub they have a button that says download a zip file archive of this project. That doesn't really fit with the rest of the rendering of the web page. You don't need to pre-build zip files because it's so rarely used. So that's another good service. It's something that can be done sort of offline, separately from the regular Rails app. So things that are hard to test, things that have a very different performance criteria, things that have a very different usage criteria. So at Zendesk, we have sort of three major categories of users. We have the end users, who are our customers. We have them in huge numbers visiting the site. Each one only performs a few requests per session. They'll check out a ticket, read through some latest comments, and comment back. Then we have agents who vary widely in scope. We have some mom and pops that just do a few tickets a day, but we have agents who are in there teams of agents that are in there 24/7, someone who's working there for 8 hours in a row. And that's a very different performance characteristic. And then we have admins who pop in and out just to configure. So we sort of have 3 different products. We have the end user product, the agent product, and the administration or settings product. And those makes for some pretty good divisions. So where it's painful to test, where you have different performance, and where you have different usage characteristics. Anything else? Yeah?
Just curious, how far down the line are you on this process? It sounds like you still have the Rails 2 app. How big and muddy
Yeah.
is it? How many engines do you have in Rails 3?
So we have a small handful of engines in Rails 3. We have, I would say, maybe 3 or 4 features in Rails 3, and we have probably on order of 30 to 50 features in Rails 2, depending on how you break up a feature. I think our strategy right now is to upgrade the classic app to Rails 3 and then sort of merge these rather than break pieces off of Rails 2 and move them over to Rails 3. But the nice thing about this is that at any point, if we decide we want to have more services, each of these engines can just be stood up as an independent Rails service. So in Rails 3, a Rails app is an engine. If you were to go into the console and you say my application.ancestors, Rails engine would be one of them. So it's really easy to take an engine and upgrade it to a Rails app. You just add a config folder. Your notifications would cease to work. So you would then need to have your service layer have a better notifications, something like 0MQ or something to do cross VM communications, notifications. That's a good point. Who else? Nothing? All right.
So you said that you're planning to go full SOA. In any specific plans, or do you have any plans to migrate at least one app? And how do you do that?
So I think the thing that I've heard most people talk about lately was in Zendesk, part of the business model is you can build background sort of processors that will act upon tickets as agents automatically. Called automations. There's also target triggers, which happen sort of in an evented model rather than a timed model. And those are 2 things that, to an earlier point, have very different performance and usage characteristics than the website. So those might be good candidates for breaking out. Also, again, the admin interface would be a good candidate for breaking out. So I think the rules that I said earlier are exactly what we've been looking at. And we're always looking for opportunities to find a service that that is a good fit for something external. Of course, there's also the argument of if you have something that really needs to run on a different kind of runtime. We run our chat on Node because there isn't a really solid evented framework that we had the skill set for in Ruby. So that was a piece that really is a separate service. In the back? Nope. Okay. All right. Well, that's all I've got.